Hello friends, welcome back to our CCNA 200-301 series. Today is video number 62. In video number 62, we are starting IPv6. We are going to discuss some theory about IPv6 and we are going to do simple lab in packet tracer. So let's start. So see here, as we see IPv6, as we know IP address is a logical address and it is a network layer address, that is layer 3. And we know we have two types of IP address, that is IP version 4 and IP version 6. Whereas IP version 4 is 32-bit address in decimal and IP version 6 is 128-bit address in hexadecimal and divided into 8 segment, that is 8 block, and each segment is divided into 16-bit. Like if you remember, in our IP version 4 we wrote like this 192.168.1.1 or something /24 like this, and this is 8-bit, each is 8-bit like this, you remember. But in here in IPv6 each will be 16-bit and we will write like this 201 : then ABC : 00004 times : 1A0. I am giving any example like this. We will have 8 segment, 8 block we will have 1 2 3 4 and more 4 we should have something. Okay, so we will have like this 8 block and each block will be 16-bit, 16 like this. Okay, I will show you example. So this is an example for the IPv6. So now everyone is having the question, we have IPv4 and we are happy and we are doing labs in IPv4, we know subnetting and we are using NAT. Then why we need to learn IPv6? Maybe some our guys is having the doubt why we want to learn IPv6, because as we know we are shortage of IPv4. Nowadays everyone is using internet, everyone is using IP address, everyone is using device, smartphones, laptop, electronic gadgets, everything, everyone want to access the internet. So we are shortage of IPv4. Before what we done, temporary solution, we do subnetting and we do NAT to access our private IP to public IP and to do anything to manageable. But this is a temporary solution even though we are a shortage of IP. So for that purpose we have IPv6. Now some countries started already using IPv6. So it is good to learn, and also we have in our syllabus, so we need to have the idea about IPv6. So if you let's go to the IPv6, we will see some features. If we see IPv6 feature, simplified header. We have header for the IPv4, IPv6. We are going to discuss both together in this video or maybe in next video. So compared to IPv4 header, compared to IPv4 header, IPv6 header is simplified header. And next point is large address. In IPv6 we have large address and end-to-end connectivity, means no need to do NAT. It can connect to one IP to another IP directly without NAT. Like if you want to access internet without NAT, you can access if you are using the IPv6, okay, in the particular private public range. Okay, I will show you that one. Let's have the introduction about the IPv6. And auto configure IPv6 support both stateful, that is stateful means DHCP IPv6, and stateless, that is self configure, that is host itself generate the IPv6 by adding some bits to its MAC address. So this is supporting IPv6 supporting auto configuration, means it is having stateful. Stateful means you can with the DHCP server we can get IPv6 or host itself can generate. Okay, so automatically it will generate, it will add some bit to the MAC address and it will generate the IP address. We will see that one later. And IPsec, that is security. IPsec is enabled in the IPv6 and no broadcast, whereas in the IPv4 we have broadcast, but here we will not have any broadcast. Okay, and it is fast forwarding or routing, because this IPv6 header is simplified header, so compared to IPv4 routing, it is faster and it will process the packets. So it is fast forwarding routing. And here we have anycast support. Anycast support means, see here, example, I am sitting here and I am connected to my home router that is connected to internet router. I have one router here. If you consider in internet, we have many router connected going from here, and it is connected to one server here. It is connected to another router. Again, it is connected to another router. We have 3-4 router here, and at last I have one server here, and here also I have some router, and here one server is connected. Example, this is Google server. Okay, this is Google server, this is a same Google server. So what we are doing when we are using IPv6, we will assign same IP address to all Google server. So all Google server will have the same IP address. So when I ping the Google server, so router will check which Google server is nearest to me. He will forward my traffic to that server. He will not forward here. Example, this is country A, country B, country C. It will forward to country A. It will not forward to country C because we have more router. Example, if you open www.google.com, in which country you have, it will come .com, .sa, .com, .uk, .com, USA, like this you will have, right? Because it will redirect your request to nearest server with the help of anycast support. So we will discuss that one also. Now you remember anycast means we will assign the same IP address to multiple server, and when we are going to access that IP, whatever the server is near to us, we will access that one. This is a concept of anycast IP support. And mobility means if you type in Google Chrome what is my public IP address, it will show what ISP is assigned to you, that public IP address. And this IP address is changing like every 4 hours, sometime 12 hours, sometime 14-15 hours. It is changing because IPv4 is shortage, and it is changing always. If you are not using, it will assign to other guy. When you are using whatever is free, it will assign to you. So it will moving like this. But IPv6 you will have permanently, you will use that one. Even if you are moving to different place, that IP will not change, you will have that one. Okay. And smooth transaction means you can make communication between IPv4 to IPv6, but not directly. We need to use some techniques. With the help of that technique, we can make the communication with IPv4 to IPv6. And as we know, IPv6 is 128 bit, and it is having the 8 segment. Each segment is 16 bit, and it is written in hexadecimal, and it is classless, means we don't have class A, class B, class C like this here in IPv6, and no broadcast. And backward incompatible means directly IPv6 cannot communicate with IPv4. IPv6 cannot communicate with IPv4. So we need to use some techniques to make the communication between them. And we need to know how to convert the decimal to hexadecimal and binary. As we know, hexadecimal from 0 to 9 will be same as a decimal, but 10 will become A, and 11 become B, and 12 become C, and 13 become D, E, F, like this, as we know this one. And how we will convert this one, 8 to, as we are writing 8, 4, 2, 1, so we will put 0, 0, 0, 0, 1 to convert into binary. So just remember this table. So we are going to use in the coming videos. Okay, so this is the idea how we are converting. Now the IP which we are using is in hexadecimal, IPv6. Before what we are learning, that is in decimal, that is IPv4. So this is example of IPv6. They will have some block colon like this. This will be 8, 1, 2, 3, 4, 5, 6, 7, 8. And each will be 16 bit like this. So total will be 128 bit. Okay, as we discussed here just now, this one 128 bits. Okay, so here if you see, we have some rules to write this one, but before going, this is a sample. This is an example of IP from here to here. This is an example of IPv6. Okay, here what we can do, by looking this one, maybe you are afraid, oh, this much big and very big this one, but no issue, we can short this one. See here, if we have 0 like this, 0 like this, 0, we can remove this 0 and we can write the colon. How? See here, I wrote same thing is equal to, we will write same thing. Let me write here, I will show you. See what we will do. I will take this 0 from here to here, or let me copy this. I will copy this address, whole address I will make copy. Okay, this is like this. Okay, so I will write here this address. So what I will do, I want to short this address, means I will remove this 0 and I will put double colon. So this we will have double colon here, and that 0 will gone. And if I know 0 before some digit, I can remove this 0 also, like this. Okay, but see here, I remove this 0, but you cannot remove this 0 because before this 0 AF, so we cannot remove like that 0. Only we need to remove whatever 0 is before that number and in between. So if you see here how many segment we have, or how many block we have, 1 2 3 4, this is 4 5 6 we have, but total as per our IPv6 we should have 8. You remember we should have 8, but now here we have 6. This is 1, this is 2, this is 3 4 5 6 7 8, so 2 are missing. So we can add 2 time like this, 0 0 colon 0 0 0 0, so it become original format. So we can do short like this also. Okay, did you understand or any confusion? Just I want to show you, that's why I done that one. So we can short the IP address, whatever is in big we can do that one in the short also. See here what I am saying, here this all are 0 0, so I will remove, I will put double colon that one. Okay, but in case if you have 2 time like 0 0, here also you are getting, here also you are getting, so you will remove the 0. How you will remove? You will remove from here also, here also? No, you cannot remove like this. You need to remove only 1 time. If you remove 2 time, like example, if you remove, let me show you here. Example, I will copy this, I will paste here and I will remove and I will show you. See here, if I have this, if I want to remove 0, I will remove maybe 0 like this. Okay, so double colon I have here. Again if I remove 0 here also and write double colon, then confuse how many bits should come here and how many bits should come here. If you count 1 2 3, so we have 3, total should be 8, so 4 5 6 7 8, more 5 bits are missing. How many I should insert here and how many I should insert here? So that's why what we will do, we will remove only 1 time as a 0 which we want to remove. We will not remove the 0 all the 0. So what we can do, wherever we have more 0 we will remove that one. So see here what we will do, I will not remove the 0, this one. Wherever we have more 0 we will remove that 0 only. Example, I will remove like this and I will put double colon here. So by seeing this one you can count 1 2 3 4. So 4 after 5 6 7 8 blocks, so you can add that here, so it become original. What you can do here, you can remove all 0 and keep 1 0 here. Okay, you can write like this, you can remove all 0 and keep 1 0 here, and you can remove all 0 and keep 1 0 only here, like this. This is the shortest v6 IP address. Okay, did you understand? So I wrote here only remove the leading 0. Leading 0 means if the 0 is coming, example, let me write here something, I will explain here. See here, example, if we are getting 2 0 before CC, so what I am saying, remove the leading 0 means you need to remove like this 0 whatever is coming before. If you are having, example, if you have here like 1 0 here, I have all 0, so let me write here. If you have 1 0 here and then A B, or you will have A B C and 0 colon like this, so we can remove this 0 and we can keep like this. Okay, I mean this one. Okay, so remove leading 0, this is the first point. And if 2 block segment contain the consecutive 0, omit them all and replace with the double colon. That is, this means if we are getting continuously 0, which one is more, we can omit, we can remove this one and we can replace with double colon this one. Okay, and this third point, colon is must be used to represent the large number of 16-bit set of 0 as possible. Means only large number we will use. If we have 2, we will not use for all 2. And if they are multiple place where colon can be used, number of 0 are the same. Example, if we have both side will be same 0. If we see example, let me do here. If I make here, let me write 0 0 0 0, then colon 0 0 0 0. Count this how many bit? 1 2 3 4 5 6. Then we need to write something. I will write A B C D 7. Then we need to write some more. I will write this. Let me write here A B C C. So we have 8 bit, right? 1 2 3 4 5 6 7 8. 8 block we have. If you consider we have 2 times 0 here, we have here also we have 0. So what we can do, we can write 1 0. Okay, to short that one I can write 1 0 like this. And if you see here also I can write 1 0, and here also I can write 1 0 like this. But if you see we have 2 times 0 0, 2 times 0 0. If we have same type, both quantities same, then what we can do, if we have more here, I can remove this one, but both are same. So then what we can do means, see here this point, use on the leftmost side, means I will use from the left hand side. So I will use this one, I will remove this one, I will keep colon. So this is a rule we need to follow, these 4 points when we are making the long IPv6 IP address to short one. Okay, I hope you understand, right? Anyhow, no problem. Try to watch again and do the practice. And if you have doubts, you can write in the comment. And when we are doing more labs or everything, we will repeat this one. So you will have more idea about that one. Now IP types of IPv6 we have here: unicast, multicast, anycast. Unicast, as we know, 1-to-1, that is data sent to single host, and range is here 2001 to /16. This is a range for unicast. We have multicast. Multicast means deliver data to group of destination, means whoever is interested, we will deliver to that group, and range is FF00::8. Anycast, as I told, it is very similar to multicast. Assign the unique address to move to more than one interface to make a unicast address, means we will assign the same IP to multiple server, and whichever is nearest to us, packet will go to that one, as we discussed just now, google.com or like this. Okay, so this is a anycast. Now you remember anycast don't have the range of IP address, it will use same unicast IP range. Okay, and now again unicast is again divided into 3 types, that is global address, link local address, unique local address. So what is this? Global address means it is same like a public IP address in IPv4, and range is 2000::3, and this range will start, that is 2001::, from 16. From 1 we will write 1, and we are going to assign to our PC or router like this. Okay, so if you see global address means public IP address, means you remember in IPv4 we are saying if we have public IP address, then only we are going to access the internet. Did you remember we have private, public? So same here in IPv6 we have global address. Global address means public IP address, like this is a public IP address. So if we want to access internet, we can use this range of IP, so we can access the internet. And link local means computer generate itself. So if we don't have IP address, we have option there to do automatic generate. I will show you in the packet tracer. See here, if you see here, let me open this one PC. If you go to this address, you will write auto generate. So it will generate itself. It will use FE00 this one, and it will add MAC address, and it will give that one FE80. So see what he generate, FE80, same range, and then he will add some bits and MAC address and all that one. So computer itself generate, that is known as link local address. Computer is generate itself, and range is there, and this is not routable, means we cannot access internet with this IP address. And we have unique local address. Unique local address is same like a private IP address as we have in IPv4. that is in our local LAN, we can assign that one. With this IP we cannot access internet, and range is FC00::7. Okay, so this is a basic point you need to remember. Now we are going to do one lab in the packet tracer, and coming videos we are going to learn more little about the IPv6. So let me show you. This is a two computer I connected. So what I will do, I will go here and then I will go to the IPv6. If you see here, we have IPv6. Let me zoom in this one. I will zoom in this so you will have the idea. This is a computer I open. So if you see here, we have this IP configuration we are using for IPv4. Now if you look here, we have IPv6 configuration. So if we want to use DHCP, we will select this. If we want to generate auto generate, we will select this. If we want to assign, we will select static. We will write static, then we will write 2001 and then colon. As we see here, we can give any IP address. This one we will give :/16. Okay, so we will write colon and range. It is range is starting from 200:/16. So I will give same like this. I will write colon, double colon I will give, means all are 0, then here 16 I will write. Okay, then I will go to, I will write here colon colon, then I will write 1. I will copy the same thing. I will go to other PC, this PC. Let me assign here. Already we have colon colon 2. So let me write this 2 and here 16 already assigned. Let me copy. So we can ping and we can check it is working or not. So I will copy this address. So this is a IPv6 address. I assign. I shorten this one. If you want, we can write long one also. I will show you long one also. First we will see short one. So I am going to ping from this machine. So I will go to this ping. Then I am going to write ping and I will write that IP address and I will put. See, reply is coming, means both computers are communicating. If you want me to give the big address, means I can give the big address. I will show you. See here, we have colon colon. So we have 8 block. So you need to write 8 block. Then what you will do, you will remove this one colon is there. Then we will write 0000 4 times. Then again 0000 4 times. Then 0000 4 times. Then again colon. How many block we have or segment? 1, 2, 3, 4. We need to give again 0000. This is 5. Again colon 0000. Again colon. How many we have? 1, 2, 3, 4, 5, 6. So now this is 7, 000. And then colon. And now we will write 0001. We will write 1. Okay. Why we will write 1? This IP is as we given the 2001 and 01 colon colon 01 we give. Okay. So now I will do this one and now I will going to ping again with the one is long, one is short. See, reply is coming, again reply is coming. One PC assigned with the longest form and another PC assigned with the shortest form. But even though it is pinging, if you see, it becomes shortest form. Just now we assigned long form, but it becomes shortest form. So we can use any one, but don't worry by seeing the IP address, maybe you will confuse. Oh, this much long we need to remember, means we will do short, no problem. Whatever possible for points we will use and we will do that one. So in the packet tracer we learn that one how two PCs are communicating. Now I can example if I don't have any IP address, so I will click this one auto configure. So he will take this link local address, that is computer will generate itself. So this one computer generated, I copy this one. Okay. So this is for PC1. I will go to PC2, this PC also, I will click here also auto generate. And what I will do, I will ping from this PC to this PC. Okay. Well, let me ping. I will paste the IP address, whatever I copy from here. So see here, reply is coming. So from the self-generated IP address, what we are saying that IP address, if you remember here, this is a link local address. So if you see with the help of link local address also they are communicating. This is the address for this computer, and if you go here, this is the IP address for this computer, they generated, self-generated. Okay. So this is the address for this PC. Let me This is a PC and this PC. So I am going to ping from this PC to this PC. So I will go to command prompt. I will write ping. Let me maximize this. I will write ping. Then I will paste that address, whatever that address. See, reply is coming. So we are pinging. So I hope you have some idea about the IPv6. In next video, we are going to do some routing protocol by using IPv6. Okay. Thank you very much for seeing our video. Subscribe to our channel. Share with your friend who is interested in CCNA 200-301 series. Thank you. Bye.